Hi, good evening to all. Welcome to this memory-based question analysis and solutions for GATE 2024. I am here along with eminent professors of ACE Academy to discuss about what is the question format, the concept, the solutions, and what is the correct option. Remember, these questions we have collected from the students with great difficulty, and most of the information is correct. But in some of the questions, the question statement may not be complete, the options may not be correct, and the concepts may not be true. So to the extent possible, we have collected it in a correct manner, and let us go through it one by one. Thank you.
All the best.
Let us look at the weightage given to the subjects in ECE in GATE 2024. You can see here, unlike yesteryears, the importance and weightage is given for all the subjects almost equal. No subject is taken out or no subject is given more importance. And if you look at the number of questions appeared in each subject, you can see this. So if you come into the subjects, starting from networks to electromagnetics, how the number of questions have come. They will include 1 mark questions as well as 2 marks questions. Networks, 4 questions. Signals and system, 6 questions. Electronic devices, as usual, more number of questions came this time, 8 questions carrying 12 marks. Analog circuits, 6 questions. Digital circuits, 6 questions. Control systems, 5 questions. Communications, 7 questions. And electromagnetics, 6 questions. So you can find the importance of each and every subject in this particular GATE 2024 paper. If you look at how is the distribution with respect to the type of questions, the MCQ questions, which is going to have only one option, there are totally 39 questions are there. And the numerical answer type question, it is 18. And then the multiple select questions, there are totally 8 questions have come. So this is the types of questions have come in GATE 2024. Thank you, and I will request my colleagues to discuss one by one.
Okay, good evening. Let us see this problem. This is very simple problem. For the closed loop gain amplifier shown below, the magnitude of the open loop frequency small signal voltage gain is given. See, you all know that an op amp basically is a high gain differential amplifier. This is a differential amplifier here given. So we can use this model actually. The non-inverting terminal is this node and this is the inverting terminal, and here there is a feedback. So here if you want you can put a MOSFET. These two are active loads. I will just replace by a resistor for simplicity. So you can see here this is the inverting terminal and the non-inverting terminal, and there is a unity gain feedback. So in a control system you can call this as G, where G is given 40 and a unity gain feedback. So what is the closed loop transfer function? The open loop gain is given 40 and this short is the unity gain feedback. So this is the output node, and this is the inverting terminal. The inverting terminal and the output node is shorted. So what is the answer? G by 1 plus GH, it is 40 by 41, or A by 1 plus A beta. So this is going to be around 0.97. Okay. So this is the solution. Let's go for the second one. Now this problem is a problem that is repeated actually. It is already given in GATE 2002 by ISC Bangalore. ISC Bangalore have given this in 2002, but now in 2024 they have repeated it. Okay. So the transfer function of this block is similar to a Wien-Bridge oscillator. So here for sustained oscillations you all know that the loop gain A beta should be 1 or GH equal to 1. So if I take this as the feedback signal, this is the input signal, the gain from here to here is going to be 1 plus R1 by R, and the Wien-Bridge oscillator transfer function you all know that it is equal to 1 by 3 plus j omega RC minus 1 by omega RC. This is a standard one. We have already done this in the class. So you can take this term right side, 1 plus R1 by R equal to 3 plus j omega RC minus 1 by omega RC. So if you equate real and imaginary terms, 1 plus R1 by R is 3. So R1 should be 2R. And if you equate the imaginary term equal to 0, so this term should be 0. So I will put omega equal to 1 by RC, 0 minus 0, right. So your omega is going to be 1 by RC. This is the second problem. It is a simple problem. It is a repetitive question. In this question we have also given in the AS material. You can go through it. ISC Bangalore, GATE 2002, they have given the same problem. Okay. Now, yeah, see, based on memory, I think yeah, so there is this problem given, and the input here is 10 sin omega t. It is an n:1 transformer, but here it has been center tapped. So this is a full wave rectifier. Okay. Now they have asked you to find the average value is given. The average value is 2 Vm by pi. This average value, I think it is given as 2.5 by pi. It is given as 2.5 by pi. Now you are asked to find the n value here. So now you know n:1 is the, suppose if there are 100 turns here, here there is 1 turn. So that means you have made it half actually here. So this is going to be 10 by 2n here. So the peak value is going to be 10 by 2n. 10 by 2n is going to be 2.5 by pi. So you can cancel pi and 2 gets cancelled. So n is going to be 10 by 2.5. It is 4. So you are asked the number of turns here, and the average value is given. What is the average value in a full wave rectifier? It is going to be 2 Vm by pi. So n equal to 4 is the solution. So the question is find n. The question is find n, and what is given? Given V naught average equal to 2.5 by pi. So this is the given data. You are asked to find n, and this is the solution. Next, I don't know, yeah. Yeah, so you are asked to find the input impedance. So here one capacitor is given, CL, and here another capacitor CI is given. So you are asked to find the input impedance Zin. Okay, so we'll replace the capacitor by 1 by SC. 1 by SC, so we'll put a test voltage V, and there will be a current I. So we'll replace the MOSFET with a small signal model, VGS and GM VGS, and R naught is mentioned as infinite. So this is gate terminal, source and drain. So from source to ground we have a capacitor here, and here we have one more, 1 by SCI. So now you are asked to find input impedance. So we'll apply a test voltage V and find current I. Since this is an open circuit, I will be flowing here, and this current is going to be I plus GM VGS. So a simple KVL will do. A simple KVL is going to finish the problem. But before that, what is VGS? VGS equal to I into 1 by SCI. So a simple KVL will do. So what is V? V equal to I into 1 by SCI plus I into 1 by SCL plus GM VGS into 1 by SCL. So in the place of VGS, please substitute here I into 1 by SCI. So I'll take I common to finish Z. So Z equal to 1 by SCI, 1 by SCL. So this is the solution, plus GM VGS. So by 1 by SCI into 1 by SCL. So this is the solution. I think it is represented in omega in the solution. So maybe it is J omega Ci plus 1 by J omega Cl, and S square is minus omega square. So Gm by omega square Ci Cl. So the input impedance is asked. So you just connect a test voltage V, find current I. So V by I is going to give you the solution. So these are the analog questions that are given to me. So we'll see if anything comes, I will try to explain. Okay. So over to my friend.
Hi, good evening. This year signals we got 2 questions as 1 mark and 4 questions as 2 marks. Total 10 marks same. All are funny models, very easy, directly from our material, classroom discussion. Let us see what were asked. For a causal discrete time LTI system, transfer function is given. I think this is MSQ. Which of the given statements are true? Initial value of impulse response is mentioned to be 2. What is initial value theorem? Limit z tends to infinity hz. When you solve for, by taking z square common 2 plus 3 z power minus 2, denominator also the term common, of course answer is z plus infinity. So this is correct. System is stable. Both causality stability requirement is poles must lie inside the unit circle, they are inside the unit circle. Minimum phase, it is false. Why? When we solve for the location of the zeros are placed at plus or minus j root 3 by 2. 1.2 roughly approximately zeros are lying outside the. In a similar way, final value of impulse response is 0, that is also true. Because what is final value theorem? Limit z tends to 1 minus z inverse into hz. Once you substitute the given data, this quantity becomes 0. So which are the valid statements? A, B and D. Very simple model. This is a regular model. LTI system property, input x of t, LTI system is represented as h of t, y of t we are writing as what? xt convolved h of t. He wants to do scaling for it. X of 0.5t, he wants to change the input as x of, pass it through again stable and LTI, causal and stable LTI system. That is mentioned to have impulse response of h of 0.5t, asked for what is the output. What is the standard scaling property we are aware? Based on property it is given. X of alpha t convolved h of alpha t can be written as 1 by mod alpha y of alpha t. Standard property. What is that alpha number? Directly what is alpha number? 0.5. X of alpha t, h of alpha t. So for the given data 1 by 0.5 y of 0.5 t. 1 by 0.5 is 2. So it is simply 2 into y of 0. Property based. This is one of the good question. A discrete signal radian frequency is mentioned to be ohm. To get its time period as 40 samples indirectly, what are the possible digital frequencies? For checking discrete sinusoidal periodicity, what is the requirement? Omega by 2 pi ratio must be a rational number m by n form. How much periodicity we are expecting? We are expecting how much periodicity? If you check for each option, I don't want to waste our time, it is obeyed for 0.15 pi and 0.4 pi. Let us verify at least one option. Okay? If I want to choose option B, 0.15 pi, substitute here 0.15 pi by 2 pi equals to m by n. Further simplification, this can be written as 15 by 200 equals to m by n. Remove the common multiplier. We got periodicity of 40 samples or not? Of course, these two will be failure. Okay? Chance for option B and D, where it obeys this condition and having periodicity of 40 samples. What must be the digital frequency to get this time period is the question. Very simple. Those who are thorough with this condition, they can answer this model. Okay? I think this is also another MSQ we got. This one DFT question. That is also very funny. Last year GATE, it is asked when you apply 2 times DFT, what will happen? This year it happened for 4 times DFT. Generally, x of n has n point DFT of xk. Here it is mentioned as 4 samples. When you apply 4 times DFT, y of n is simply n square times xn. We discussed in the class n square into xn. That is indirectly n square means 4 whole square, original data 1213, 121. So it becomes 1632, 1648. What is asked here? What is the value of y0? Spectrum at 0. Spectrum at 0 corresponds to what? Area under the signal. Sigma 0 to 3 yn. Just we have to add all the values. Spectrum at 0 is expected. Solve that number. You will get 112 after simplification. Just doing addition. Spectrum at 0. Two properties we need here. When you apply 4 times DFT, it becomes n square into xn. Additionally, area under the signal means spectrum at origin. Very easy. Properties based question, Fourier transform. Of course, I think they have missed this minus sign even in the exam. Some students are saying. So, how to express the relation between the spectrums of yt and xt? Funny. xt length is 1 unit, yt length is 4 units. What do you have to do? Simple expansion. So, if you think that way, 1 unit length, but here we are expecting 4 units length. Let us go for x of t by 4. Let us go for x of t by 4, something like this. Minus 4 to 0. But you want the same graph for which interval? Minus 2 to 2. When you have scaled signal form as x of alpha t, what is the shifted form? Alpha into t minus t naught. When you have scaled signal form as that one. I have to make right shift of 2 units. Of course, change in amplitude. That negative amplitude now becomes positive. So I can write that as what? Minus x of 1 by 4 t minus 2. This is scaled signal right shifted by 2 units. You want negative amplitude as positive. Two properties you apply, of course we will get the answer. According to all properties, alpha 1 by 4, shift of 2 units, shift of 2 units. Take the Fourier transform, standard properties, minus x of alpha t form 1 by alpha, x of f by alpha into exponential term e power minus j 2 pi f t naught is plus 2. Convolution property they concentrated on scaling, even from Fourier transform also they concentrated on scaling property. Very simple, straightforward, very simple. Yeah, one sampling question is there, that is also very funny. Let me write the data. X of t is given as 2 cos of 8 pi t plus pi by 3 passed through sampler. The sampling rate is mentioned to be 15. Later on it is given to a filter having certain impulse response sin 2 pi t by pi t cos of 38 pi t minus pi by 2. He wants the exact output, filter output he wants. Get the filter output. Normally, what is the spectrum of sample signal relation standard? 1 by Ts sigma x of f minus nfs. So first our job is getting the frequencies at the output of sampler. Get the frequencies at the output of sampler. That can be decided by fm plus or minus n into fs. Fm plus or minus n into fs. The beauty of this question is based on the ABCD options without solving you can decide, because only this term, what is the filter? Sin 80 by pi t means a rectangle from minus 2 pi to 2 pi. That is modulated by 38 pi units. So when you shift it, it is covering the range 36 pi to 40 pi, 36 pi to, of course I am taking magnitude, phase angles we will add in the answer. Okay, mod h omega. So he wants exact output according to the given options. Of course, for me, I don't want to write all the options here. 38 pi is given as the option. 38 pi frequency is required or not. When you find the frequencies at the output of sampler, that is fm plus or minus nfs or omega m plus or minus n into omega naught. What is omega m? 8 pi plus or minus n into 30 pi. Omega naught is 2 pi fs. Okay. 38 pi chance is there. n can be varied from minus infinity to infinity, 38 pi chance is there. Filter output he wants 1 by Ts tag compulsory, this extra tag 1 by Ts, that is there. Here you have 2 already, to cancel this 1 by 2, that 2 is given. See the beauty, that to cancel that 2 multiplier 1 by 2 is available, 15 cos of 38 pi t, phase angles are added. What is the phase angle of that one? Pi by 3 minus pi by 2 is the phase angle of the system. After simplification, this is minus pi by 6. All funny models, very simple questions that were asked in the exam. So I am handing over to the next faculty member. In control system asked 5 questions for 8 marks. So this is the first question, it is very easy question. So in the content of board of magnitude plot, 40 dB for decade is same as, so we know the conversion, so that is plus or minus 20n dB for decade equal to plus or minus 6n dB for octave. So here given 40 means 2 times, that means 12 dB for octave. Option B. The second question, G of S given, find K so that T impulse response of closed loop system decay faster. The word faster comes means it is we can get the time constant. So once we get the time constant, then we can find the K value to get the faster response. So here e power minus t given, from this you can get the time constant, e power minus t. If you compare with e power minus t by tau, the tau becomes the 1 second. So this question belongs to relative stability concept. So we require to shift the axis location and then we require to convert S in terms of the Z and then we have to solve it. S equal to Z minus 1 by tau, we discussed in the class the relative stability concept. So where tau equal to 1 second, that means S should be replaced by Z minus 1 in the given system. So you replace S by Z minus 1. So what you will get? G of Z minus 1
equal to k divided by z minus 1 plus 1. So, z minus 1 plus 2, z minus 1 where it is? Z minus 1 plus 3. So, then you simplify this k by z, z plus 1, z plus 2. You write the characteristic equation. The characteristic equation becomes 1 plus g of z minus 1 equal to 0. Then if you write, this will become z cube plus 3z square plus 2z plus k equal to 0. Then internal product is 6, external product is k. So, the stability condition is k greater than 0, less than 6. Then the poles lies the left of the what? S equal to minus 1. Then the response become the decay, then more quick decay than e power minus t. That means the option is what? So, 1 to 5 is in the range of what? 0 to 6. So, the answer is D. Next one is, consider the feedback control system given below, and he asked the error E of t. For steady state errors, the system must be stable. First of all, you have to check the what? Closed loop stability. But you observed here, the characteristic equation becomes 1 plus g of s equal to 0. Then if you write characteristic equation, you will get s cube plus 3s square plus 2s plus 6 equal to 0. If you do the internal product 6, external product 6, that means the given system is marginal stable. Steady state error calculated to only closed loop stable systems, but given system is marginal stable. That means steady state error is does not exist. Steady state error does not exist because C of t is oscillatory. Next here, they are asking the alpha value. Here alpha is there. So, and what they are telling, for the poles are present at minus 1 plus or minus j root 3. Then the final value of alpha they are asking. If I write here g of s, the g of s becomes what? K into s plus alpha divided by s square into s plus 4, and h of s is 1. If write the characteristic equation here, if I write characteristic equation, that is 1 plus g of s equal to 0, if write characteristic equation, so that will become s cube plus 4s square plus ks plus k alpha equal to what? 0. For given data also we require to write the characteristic equation. So, for given data, what is the characteristic equation? 1 minute. For given data, what is the given data given? S equal to what? Minus 1 plus or minus j root 3. If I write characteristic equation, s plus 1 whole square plus root 3 whole square equal to 0. Then if you write this, expand it, s square plus 2s plus 4 equal to 0. But for given data, the characteristic equation is what? Second order. So, but we required what? Third order system. So, that means we need to assume the what? One pole. We will assume a pole at minus a, third pole. Assume third pole at minus a. Third pole at s equal to minus a. Then write the characteristic equation. So, that is s plus a into s square plus 2s plus 4 equal to 0. Expand this and compare with the what? The given system characteristic equation and solve it, you will get the alpha equal to 1. You will get the alpha equal to 1. The answer is what? B. Next one is one question asked on state space analysis. 1 minute. So, they given a state space state model, they ask the transfer function x dot equal to 0, 1, minus 2, minus 3 and x here given 0, 1 and u and y equal to minus 2, minus 5 and x given. They ask the transfer function. So, transfer function equal to C into Si minus A inverse B plus D equal to 0. So, this can be written as C into adjoint of Si minus A divided by det of Si minus A B plus D, B plus D. Is it not 0? Sorry. Right. So, you write Si minus A. If you write Si minus A, so you will get S here minus 1, here plus 2, S plus 3. This is Si minus A. And then you substitute here C. What is C here? Minus 2, minus 5. Then adjoint. Adjoint means S plus 3. Here S, here plus 1, here minus 2. And then here B. B is 0, 1 divided by det of Si minus A means S square plus 3S plus 2. If you solve this, you will get the answer is minus 2 minus 5S divided by S square plus 3S plus 2 is the transfer function. So, that is all. Next our colleague will come.
Hello friends, myself Sriram. Let us solve the questions from the digital electronics, okay, from ECE gate. And you see, this is a question given, the Boolean function f of a, b, c, d, 4 variable function is provided, and sigma m. So, given is a SOP function and all are minterms. And he asks, just question is about like essential prime implicants, number of essential prime implicants. So, directly we can take the K-map, 4 variable K-map, and I am not writing the minterms in the K-map. I would like to load the K-map directly from the given minterms of the function. Okay, AB and this is CD 0 0 0 1 1 1 1 0 0 0 0 1 1 1 and 1 0. If you take these numbers, see M0, M1, M3, M2, M4, M5, like that, you have to write up to M15. Then we will get minterms like 4 minterms like this, 1 1 1 1, these are the minterms, and 2 minterms will be here, right. Then let me go for the grouping. 1 2 3 4 5 6 7 8 9 10, right. So 4 plus 4 8 plus 2 10, all 10 minterms are available in the K map. So we can take all 4 corners as one quad. I can take all these 4 bits as one quad. Totally there are 4 groups now, sorry 2 groups now, and another quad here. And is there any possibility? Yes, we have another 2 possibilities. This is one possibility and this is another possibility. Total number of groups, all 4 corners 1, 4 minterms 2, 3, 4 and 5. What is this 5? Prime implicants. But what is the question? Essential prime implicants. Out of 5 prime implicants, there are only 2 essential prime implicants, because in this quad these 2 minterms are participated in grouping only once, so that this can be essential prime implicant. Similarly, see this quad, these 2 minterms participated in the grouping only once, it is also essential prime implicant. What are the corresponding equations or minimized Boolean expressions for them? For this quad, B and D, B dot D, plus for this quad you will get here the common terms D bar and here the common terms B bar dot D bar. So B is the correct option, right. Yeah, see this question. This is a routine model. Generally we have discussed this question to find the frequency and to find the modulus number of the counter, like that. Here the question is given for the sequence. Whatever may be the counter, if you don't find initial data, generally in our routine practice, we will take 0 0 as initial state and try to recall the data or some information about T flip-flop. If T value is 0, if you apply the clock pulse, what will be the output? It will maintain the previous state. When T is 1, if you apply the clock pulse, it will be toggle. Toggle means complement of its previous state. So that in spite of the options, blindly we can follow our basic rule. Generally we are starting the sequence with 0 0. I am not taking the elaborated table of this. Directly I am writing T1 expression here. What is the expression for T1 here? T1 is equals to OR operator, see OR gate output. So one input is Q1 and another input is Q0 bar. So that Q1 plus Q0 bar. What is the T0 expression? T0 is equals to Q1 plus Q0. Let me take the sequence with the Q1, Q0. You see the question is given for Q1 comma Q0, that is the order he asked. So that I am assuming the clock here, when no clock is applied, that means what? It is the initial data, right? I am taking it as 0 0. Initial data is 0 0. Now you see guys, Q1 value is 0, Q0 value is also 0, right? Initially 0 0. If it is 0, its complement is 1, 0 bar value is 1. So 1 plus 0, T1 value is 1, or generally in the table we will substitute it. Q0 value 0, 0 bar 1 plus 0, T1 value is 1, like that. Now T1 value is 1, and what is the T0 value? 0 plus 0, 0. So that this is 1 and this is 0. If I apply the clock, first flip-flop will toggle, second flip-flop will maintain its previous state. So that 1 0 will come after first clock pulse. After first clock pulse, 1 0 will come. Now Q1 value is 1, so 1 plus anything, T0 is 1 now. Second flip-flop is ready to toggle. What is the Q0 value? 0. 0 complement is 1, so that 1 plus anything is 1. So both the flip-flops are ready to toggle. They are ready to toggle. Once if you apply the clock, both the flip-flops T1 and T0 will be toggle. Toggle means complement of the previous. That means what? 1 will become 0, 0 will become 1, right? So 0, 1 will be the next states producing by this counter. So that I am updating the outputs here. We can take it as a table, but just I want to give you the quick answer, hence I am not taking any table. Directly I am explaining on the circuit. So what is the updated data? Q1 value is 0 and Q0 value is 1. Now as Q0 value is 1, 1 plus anything T0 is 1. Its complement is 0, this is 0, right? This is already 0, that means the readily available inputs of T1 is 0, even T0 value, right? What is the T0 value? See, 1 plus anything, this is 1. That means it is not going to toggle, but second flip-flop is going to toggle. That means what? This is maintaining previous state, this is going to toggle. What is that state? 0, 0. So if I apply the next clock pulse, 0, 0 will come. What is that 0, 0? It is the initial state. So the circuit can produce a sequence like 0, 0, 1, 0, 0, 1, next 0, 0. See my dear friends, observe the options carefully. We don't have this option, this answer in any option, but we can select the correct option. Why? You see 0, 0, 1, 0, 0, 1, 0, 0. What will come? 1, 0, 0, 1, 0, 0. 1, 0, 0, 1, 0, 0. This sequence will be repeated. So I can say this 1, 1 might be the lockout state. So initially he is asking you to find the sequence from 1, 1. Sir, if I take 1, 1, compulsory it should lock into 0, 0 state. Yes, you can check it out. You just assume initial value of Q1 is 1, Q0 is also 1. If this is 1, this value is 1, and as this value is 1, T1 is also 1. T0 1, T1 1. After 1 clock what will happen? Both the outputs will be toggle. 1 toggle 0, 1 toggle 0. So that initially even if you start with 1, 1, system will enters into 0, 0 and it will not reach 1, 1 again. It will keep on repeat from 0, 0, 1, 0, 0, 1. So that C is the correct option. C is the correct option, right? This is the direct question. Propagation delay of this multiplexer is 10 nanoseconds. NOT gate delay is 0 nanoseconds, 0 seconds. S is initially set to 1. We have done these models, but we have connected Y directly to the select line with the appropriate input data. This is another way to design an stable multivibrator, right? See, assume some data. If no data available, we can take some assumption. I am assuming output as 0. Output 0 means this value is 0, its complement value is 1. So 0 and 1 are available informations at I0 and I1 respectively. What is the S value? 1. So that this 1 is connecting to output. After 10 nanoseconds, what is going to be the output? 1. If this now updated data, this is 1 and its complement is 0. S is fixed at 1 so that 0 will come to the output. So output will be a square wave. What is the on time? That is a time duration or time duration for which output is locking at logic 1. So how long it will be 1? As long as the system is changing that 1 into 0, that is only the delay of 10 nanoseconds. So that here on time is equals to off time is equals to 10 nanoseconds. So what is the total time? 20 nanoseconds. What is the frequency of this square wave? 1 by time, that is equals to 50 megahertz. So output is a square wave and producing the square wave at 50 megahertz, right? So D is the correct option. A 4-bit priority encoder has inputs D3, D2, D1, D0 in decreasing order of the priority. The 2-bit output is generated as 00011011. Generally, if you read this question, you may feel Sir, this is a as it is question available in textbook or maybe in our notes. No, this is slightly different. Whatever the general model we have, for that the priority value is given exactly opposite. Now you see the continuation statement, the 2-bit outputs are generated as 0001 1011 corresponding to what? D3, D2, D1, D0. In general it should be D0, D1, D2, D3, but he has given it as D3, D2, D1, D0. And the Boolean function of B is, right. So let me do it here. Generally what is our procedure? Yeah, one second. See, D3, D2, D1 and D0, output lines of this priority encoder are A comma B. What is our general pattern? 0, 0, 0, I am assuming D0 only selected. Then you will get 0, 0, that is the routine model, right? But here we are going to take opposite options, opposite assignments, right? So 0, 0, 1, what about this? Don't care, as per the general procedure, right? Priority is increasing to higher order or decreasing towards the lower order. So 0, 1, don't care, don't care, and whenever D3 is 1, we are ignoring all like this. So if D3 is selected, what is output has given corresponding data? If D3 is selected, output is 0, 0, like that's why I am writing 0, 0 here. 0, 0, 0, 1, 1, 0 and 1, 1. Sir, what if all inputs are zeros? Generally we are taking false data detection or otherwise what we call selection line, but no data is provided. That's why for all zeros case you have to take it as don't cares. Output should be don't care. That's it. Then let me take B values. We are going to find the expression for the B, right? We have to take the expression for B. So B is equals to 1 for two cases. B is 1 for 0001. You can write 0001 or directly you can write M1, no problem, right? M1. Magnitude is 1. B is equals to 1 for 01 don't cares. 01 don't care means 00 to 11. So that 4 to 7. M4 to M7, right? So we need to take a 4 variable K-map. D3, D2, D1, D0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, right? So let me take these numbers directly. M1, this is M1, okay? This is M1. M4 to M7, M4 to M7. And remaining all are zeros. But how can I take all zeros case as 0, 0? There is no status signal information provided. Even you can try, this is the data we have obtained from the memory base, right? So as per the data provided by the students, we got these options. So these options cannot satisfy if we take 0. We can take it, there is a chance. Indirectly examiner is telling you that for no input, consider don't care. That is the indirect information we have to understand. Then we will get two groups. What is this? D3 bar D2, and this is another quad, okay? D3 bar D2 plus, what is the common term? D3 bar D1 bar. D3 bar D1 bar, D3 bar D2. A is a correct option. A is a correct option, right? Okay friends, these are the questions found from the digital.
Good evening all. In network theory, 4 questions we got. Let me take one by one. Guys, if you see that this question, the switch S was kept open for a sufficiently long time and is closed at t equal to 0, the time constant for t greater than 0. Guys, this is very simple. I think I have provided that think without ink, you can answer this question. Once you identify the separable point of this one, 3 Henries, and by making this as an open circuit, 2 and by making this as a closed, then nothing but what, for t greater than 0, 4 and 4 are connected in parallel, total in series with 2, total R equivalent value is equal to 4 ohms and L value equal to 3 Henries. Then directly for LC circuit, you know that time constant is equal to L by R equivalent, L value is given 3 and R equivalent just now I have given that 2 plus 4 parallel with 4, you are getting that 3 by 4 which is equal to 0.75 seconds. The answer is 0.75, this is the NAT answer, that is why you need to type with the keyboard 0.75. Let me take the next question. Right, this is the fundamental DC circuit analysis it was given. This question also you can answer with one step. The question is from the given circuit the current Ix is the current passing through the 1 ohm resistor, 1 kilo ohm resistor here. If you want to get it this Ix value, first of all this question you may think that it is the supernode concept, but it is not the supernode concept. You can take with one equation you are going to get that Ix value. First I would like to define that what is Ix in terms of the given values. By taking here a KCL here, 5 milliamperes is incoming, I naught is outgoing. Since the dependent source is 1000, I naught is given, I naught is the control variable, and the current in this direction I can take it 5 milli minus I naught here, and it is coming here, and this is the ideal current source. Even though resistor is present, ideal current source series resistor can be neglected, I think you know that, and 2 milliamperes is leaving out of 5 milli, then rest of the current is 3 milli into I naught, is it right? Nothing but Ix value is equal to 3 milli minus I naught. Now our focus is on I naught. How you are getting that I naught value? According to the direction of the current, I can take it here, the polarities of across resistors, and by making the KVL for this closed path. This is the important equation here. From this I can take it by KVL for I naught. See this one here, minus I naught into 1k and minus 1000 times of I naught, same 1k I naught, and plus 1k times of here what we are considering 3 milli minus I naught is equal to 0. Now with this I can take it after simplifying you are getting that 3000 I naught is equal to here 3 milli into 1k means 3, I naught value you are getting that 1 milli. But guys here I naught is this is not our required value. Our required value is the Ix which is 3 milli minus I naught, where I naught is equal to 1 milli, that is why you are getting the 2 milli amperes. In milliampere, this is also NAT, numerical analytical type, that is why the answer you have to type there as answer is equal to 2. You have to type with the keyboard is 2. Let me consider that next example. Right, this question is under network theorems. For maximum power transfer theorem, what is the value of RL? Now RL is variable. Guys here network, if you see that the same type of question which was given in the previous examination, but the calculation part is very important for this one. That is why only RL value is required. To obtain that RL value, R Thevenin's is required. While finding the R Thevenin's, when the network presents the dependent sources, definitely we should go for that universal method. That method is nothing but a VA method. By taking that VA method, you should go for R Thevenin's, all the independent sources should be deactivated, nothing but you need to make this as a short circuit. Now you are getting by making voltage source, if you connect the voltage source, then the current is exciting I by assuming that you are getting
the value of R Thevenin is equal to, it is the ratio between the applied voltage and resultant current. Now guys, once you see that here, the value of voltage, node voltage is V. And once you identify that here, the control variable is Vx. Vx is defined voltage across the 3 ohms resistor. He was given the polarities. As per the polarities, I can define the current direction. If you define the current direction, this current value, I will take it here. The current value is equal to Vx by, this value is equal to Vx by 3, I can take it. But here, the value of Vx by 3 is equal to, in terms of V also I can define V minus 0, since we have deactivated while finding the R Thevenin, so V minus 0 by 2 plus 3, because both are in series, which is equal to 5. Now Vx value anyway we have to be here eliminated, that is why I would like to consider from this expression Vx value is equal to 3 by 5 times of V. Now let me take that KCL expression at this, by KCL at V value. Now 3 branches are there, incoming is here I and outgoing Vx by 3 plus V minus, what I can say that Vx by 2 is right. Now once you take LCM 6 you are getting, by simplifying that, 2Vx plus 3V minus 3Vx. Now we are getting the 3V minus Vx. Instead of Vx here we can take it 3 by 5 times of V, that we are getting 3V minus 3 by 5 times of V. This we will get it here 3, if we take common 5 minus here 3 into 4 is 12, 12V by 5 which is equal to here 6I. Now our required value for this one is what it is, R Thevenin is equal to V by I, which we are getting 6 by 8 here, 6 2 times, now 5 by 2 ohms we are getting. R Thevenin's value is equal to how much? 2.5 ohms you are getting. At what value of RL maximum power transfer? Maximum power transfer, RL value should be is equal to R Thevenin's, which is equal to what? 2.5 ohms. This is the only the calculation part here, we have to take it that option. Here answer 2.5 ohms is the correct one. Let me consider that the next one, right. Guys, this is the somewhat, you may think that this is the difficult question, but it is a very easy question. Let me take the question. As shown in the circuit, the initial voltage across the capacitor is given 10 volts. With the switch being opened, the switch is closed at t equal to 0. The total energy dissipated in the ideal Zener diode, which is having V Zener diode equal to 5 volts after the switch is closed, in millijoules up to 3 decimal places. This is also under numerical type is given. You may think that this is the time taking, but I can give a direct step for this one. If you want to get that energy, energy is the integration of the power. This is the main rule, you have to take it. And our target is estimation of the power where across the Zener diode. But here switching action is there, definitely transient response you are getting that. The transient response, whether you have to take you have to take whether voltage across the capacitor or current passing through the Zener diode, right. Now take that current passing through the Zener diode, that is I of t, in this direction, since it is the source free circuit. For RC source free circuit, definitely capacitor is discharging, under capacitor discharging current you have to take it that this you can take it I naught into e to the power minus t by tau. In this it was not provided that here 10 microfarads, I guess this is the capacitance value is 10 microfarad, since tau is equal to RC for what circuits? RC, any circuit, either series circuit or parallel circuit, R value is equal to 10K and C value is equal to 10 micro, which we are getting time constant as a 0.1 here, 0.1 milliseconds or 0.1 we are getting that, it is not 0.1 milli, it is a 0.1, right. Now once you obtain that time constant, I naught is required here. How you have to get it the I naught? Initial voltage of the capacitor is equal to 10 and Zener diode 5 volts is there, that is why the current direction I naught value, here I can take it I naught value directly I can take it what? I naught value is equal to 10 initial voltage of the capacitor, Zener diode by 10K. How much you are getting that 5 by 10K, nothing but what? 1 by 2 milli, nothing but 0.5 milliamperes. Now finally you are getting that I of t Zener diode current, what we are getting 0.5, nothing but I naught into e to the power minus t by tau. Now this 0.5 e power minus 10t. Once you obtain that I of t and P of t is required here, suppose if you consider that P of t is equal to voltage already given, Zener diode voltage 5 into I of t 0.5 into e to the power minus 10t. This is what? Watts. But here we need that power dissipated by the Zener diode. Diode is that in the same direction. Whenever if you take this Zener diode, usually you know that in reverse bias it will activate. That's why I can say that the power dissipated by the Zener diode is that expression. You should take that the energy, by taking the energy W is equal to integration from 0 to infinity. Here whatever it is given 0.25 into, this is 0.25 into e to the power minus 10t. Guys, here you have to take that this is in terms of milliamperes. Milliamperes means here milliwatts, here milliwatts, here we are getting. Now this is the only the calculation part you have to do it, 0.25 into e to the power minus 10t by 10, minus 10, 0 to infinity. Once you calculate that, here you will get it. Final answer for this one is equal to what we are getting, 0.25 by 10 into this minus e power minus infinity is equal to 0, 0 minus of minus you will get it. That's why finally here you are getting that 0 minus 1, this is minus, minus into minus plus you will get it. Here 0.25, already we are having this is milli, and 0.25 by 10 into e power minus, this is 0.1, here 0.025 millijoules we are getting that. This is what? Is it okay? 5 into 0.5 is 2.5 you are getting. Finally, see this one, this is 2.5, it is not 0.5, its value is equal to 2.5 you are getting. 2.5, 2.5 or 2.5 by 2, nothing but finally you are getting the value of total energy dissipated by the Zener diode is equal to, energy dissipated by the Zener diode is equal to 0.25, minus into minus plus, this is in terms of millijoules you are getting that, 0.25 millijoules. Once you see that, according to that in terms of millijoules, 3 decimal places, that's why the answer for this numerical analytical type you need to type with that keyboard is equal to 0.25. Okay, guys, these are the questions given under networks. So all the best guys, my colleague will continue the next subject with them. Thank you.
Yeah, hi dear students, very good evening. I hope you gave up this GATE 2024 fantabulous, right? So in electronic devices and circuits, or we say electronic devices, almost 12 marks this year you got. This is really amazing, I understand. Electronic devices and analog circuits combinedly you got around 22 marks. That's what we got input from different students. Anyways guys, let's enter into the numericals. Questions from electronic devices, okay? if you go through this very first question, for a non-degenerative doped N type, I hope you know the difference between degenerative and non-degenerative, right? This is a normal doping, right? Fermi level below the conduction band in N-type semiconductor is a non-degenerative. If Fermi level is inside the conduction band, that is a degenerative, right? Anyways, for non-degenerative doping of N-type silicon, which of the following plot represent temperature dependency of free electron concentration? That means x-axis, as per the examiner, x-axis he has given as 1 by T and y-axis concentration of electrons. Number of times I discussed this in the class, right? It's a very simple question. Guys, if you could recollect the concept what we have discussed in the class, So, for example, I say this is ECE. Let me change the thickness. Yeah, the conduction band, and I say this is valence band, energy level. This is the position of a donor level, correct or not? Where is the position of a particle? I can easily identify by the donor energy level, or we say Fermi energy level at 0 kelvins, right? So, how much amount of energy required to bring an electron from here to here is nothing but EC minus ED, a minimum amount of energy we need. So, if we are giving the lowest temperature, I repeat, if we are giving the lowest temperature than the energy required to bring an electron from here to here, then electrons cannot enter into the conduction band, correct or not? That means this N represents what? Density of electrons in the conduction band. That means the electron density ready to participate in the current. So now electrons cannot reach here. If I give a very smallest temperature, then electrons will enter into the freeze out condition. Electrons will enter into what here? Freeze out conditions. When our temperature is getting increased, yes, electrons from conduction band reach to the valence band and they will participate in the current conduction. In the similar way, if I increase very high temperatures, now tell me dears, if I increase very high temperatures, it is open secret, Fermi level will move away from the conduction band and maximum reach to the center of energy gap, where energy gap is intrinsic level. So if I give very high temperatures, Fermi level move away from conduction band, reach to the center of energy gap, then extrinsic semiconductor behaves like intrinsic semiconductor. That means at very high temperatures, yes, I can understand N-type act as intrinsic. At very low temperatures, there exists a freeze out condition. At a moderate temperature, is the operating temperature which is advisable to operate my N-type semiconductor for current conduction. That's the reason why, if you could recollect, y-axis, if I go for log n base e, and x-axis, 1 by t. So 1 by t represents, this is the region where the temperature is very high, because it is not x-axis as t, it is 1 by t, right? So here high temperatures. Whenever temperature is very high, it acts as intrinsic. And this is the place where there exists a carrier freeze out, then electron density will be falling down. So this is the way how you are going to get the graph. Correct or not, dear students? So this is the region we say freeze out region, carrier freeze out region, and this is the place extrinsic act as intrinsic semiconductor, and here the operating temperature points, which is always advisable. So this is what we discussed in the class. Intrinsic region, freeze out region, and N is almost equals to what here? ND. Therefore, if you check it out, the options as per the given question, I think option B is apt for the given question, not A, not C, or not D. I think this is very interesting question and very simple question they have asked in the exam, GATE 2024. Let's enter into the second question. See, I don't know exactly the data is correct or not. This is the data actually we got from the students, okay. So based on that, we have taken the inputs and we thought of discussing in the class right now in the live session. Now go through this question carefully, my dear boys and girls. If you go through this question, given semiconductor is at equilibrium. This is very interesting. My device is under equilibrium. I hope you know. Whenever there exists equilibrium, the total current must be equal to 0. Don't expect any carrier flow from left side to right side or right side to left side. No electron density, no electrons can be propagated or no holes can be propagated. The net current must be equal to what here? 0. That is the condition for equilibrium, right? And according to the carrier transport equation, at equilibrium, electron density equals to drift current density plus diffusion current density equal to 0. Correct or not? That is the condition of equilibrium. Please take care. Try to recollect the content what we have discussed in the class. Now, anyways, so given semiconductor is at equilibrium, and no doubt the electron density y-axis and distance x-axis. Electron density y-axis and x-axis is distance they have taken. This is the profile given by the examiner of IISc Bangalore. Now we are supposed to understand which of the following options are true or apt for the given condition. Wonderful, man. So in option A, they're asking that drift current exist between B and A. That means they're asking, I think if I am right, drift current is propagating from B to A. I think this must be the right way of asking question, because here 3 different distance points they have chosen, A point, B point and a C point. Now in the option A, they're asking that there exists a drift current between B to A. That means B to A, there is a drift current. Okay, let us check it out. And option B, diffusion current exists between C to B, C to B, C to B. This must be C to B, right? That means from C to B, examiner is asking me to say whether diffusion current exists or not between C to B. This is very interesting. And electric field exists between B to C. Okay, so between B to C, electric field exists or not. In the similar way, electric field exists between A to B. Electric field exists between A to B. Let us verify that. Students, even in our class, huge number of times I have considered the concept of diffusion. Remember or not, dear students? There exists a concentration gradient. If there exists a concentration gradient, no doubt diffusion exists. So x-axis, I say n of x, and y-axis n of x, x-axis is what here? Distance, and this is the way how they have given in the exam, the concentration of carriers. Now here he told it is A, and in the center he told it is B, and here it is what here? C. Now speak out, my dear boys and girls. Due to concentration gradient, I think electrons can easily diffuse in this direction. If electron is diffused in this direction, I think this is the direction where current density exists. So Jn diffusion current density exists. Excuse me, correct or not? If electrons are getting diffused from high level to low level, no doubt electron current density, because we need to consider conventional current direction, so electron current density must be in this direction. Therefore, no doubt electron diffusion current density, there exists, no doubt, moving from A to B. Correct or not, dear students? Electron current density is from A to B. Okay, fine. In the similar way, please let me know, my dear boys and girls, I think there is a slope, there is a concentration gradient, therefore electrons will be diffused in this direction. If electrons are getting diffused in this direction, no doubt, electron current density will be in this direction because of conventional current direction we always obey. So in that way, so diffusion current density is moving in this direction, indicates a diffusion current density is moving from C to B, excuse me, correct or not? C to B, current density is moving in this way, so C to B, right? Now tell me, he told clearly, my device is under equilibrium. Equilibrium indicates what? Once electrons are diffused from high level to low level, yes, there exist positive ions here at high level. Sorry, let me change the color. Speak out, guys, there exist positive ions at the high level and negative ions at the low level. In the similar way, positive ions at the high level and negative ions at the low level. So because of positive negative separation, no doubt there exists what, dear students? Electric field. We call it as a built-in electric field, correct or not? In the similar way, even here there exists electric field. We say built-in electric field. This is interesting. Now speak out, guys, electric field moving from positive to negative. Therefore, built-in electric field in what direction? If you ask me, it is from B to A. There exists built-in electric field between B to A, and in the similar way, there exists built-in electric field between B to C. Superb. There exists built-in electric field between what here? B to C. Okay. Sir, once again, if electric field is in this direction, it is very clear that force is in this direction, which is built-in force acting on electrons. Force is in this direction, which is built-in force acting on electrons. Correct or not, dear students? If the force is in this direction, electrons will be drifted in this direction. If electrons are drifted upward, no doubt, electron drift current must be in this direction. So this is what here? I drift. If the force is in this direction, electrons will be drifted upward. If electrons are drifted upward, no doubt, current must be down because conventional current direction. Electron drift. Wow, this is superb, man. Now let me know, guys. Of course, see, you prepared for the exam, so you can get this answer very fast, but the only for explanation purpose, you know, I'm showing all the things because all the 4 options I need to check it out, which is apt for the given data, right? So now let me know, my dear students. So drift current is propagating between B to A, correct or not? So I drift, yes, it is there between what here? B to A. So I drift is from B to A. In the similar way, I drift is between B to C, yes. I drift is between B to C, yes, because He told clearly it is under equilibrium. I need to consider drift and diffusion, and of course total current equal to 0 for sure because it is under equilibrium. So drift is from B to A, correct? Drift is from B to A, drift current is from B to A, and drift current is from B to C, yes. Now this is what exactly we got. Now check it out the options. Excuse me, first, drift current density exists between B to A, drift current B to A, drift current B to A, drift current B to A. Yes, this is right. Drift current B to A is apt. Absolutely correct. Next, diffusion current density is between C to B. Diffusion current density A to B, no. Diffusion current density C to B, yes, it is right. So diffusion current density is between C to B is absolutely right. Diffusion current density exists between C to B. See here, exists between C to B, correct. In the similar way, electric field exists between B to C. Electric field exists between B to C, yes, this is right. There exists electric field between B to C. Electric field exists between B to C, this is right. Electric field exists between A to B. Electric field exists between A to B, no. Electric field exists between B to A, not A to B. Therefore, this is wrong. I think this is a multiple select question given in the exam. Therefore, option A, option B, option C, all the three options are apt for the given question. Wonderfully, your examiner framed this question, right? Now let's enter into one more interesting question. Guys, this is the data actually we got from the student. We did not get exactly framing of the question. What data we got? That data I'm showing you here. So student said that in the exam there is a solar cell given and a photocurrent is specified. You know that photocurrent is nothing but current due to light, So which is nothing but a short circuited current. So IL or ISC, which is 1 milliamps, they have specified in the exam. And a given voltage corresponding to the maximum power output. Maximum power output. I hope you know that. If I plot the graph for a solar cell, the quiescent point must be in the fourth quadrant. Right around the student, this is V and this is minus I. The quiescent point will be in the fourth quadrant. So this is the way how we get the graph. And this voltage is called open circuited voltage and this current is called a short circuited current. And somewhere in the middle, we get the maximum power, we say the operating point. Correct or not, dear students? Here, what voltage I am getting? It's a maximum voltage. And what current I am getting? It's a maximum current. Now what examiner has given? Given voltage corresponds to maximum power output. That means he has not specified open circuited voltage. He has specified voltage corresponds to maximum power. That means examiner has given Vm is a 0.3 volt. It is not VOC. Please take care of that, guys. It is not VOC, right? Now thermal voltage is given as 30 millivolt. Commonly we consider 25 or 26 millivolt, which is at room temperature. I think the operating temperature is more than room temperature. This is interesting. And what exactly we need to find? We are supposed to find the reverse saturation current, which is a leakage current. That means I naught is how much? So I don't know whether this data is correct or not. If really this is the given data, I don't think so we get the right answer. Why? Because guys, if you recollect the formulas, we have the peak current formulae, which is IL into 1 minus thermal voltage by peak voltage. Okay, fine. What is open circuited voltage? Thermal voltage or KT by Q into log mod 1 plus IL by I naught, or simply KT by Q log mod IL by I naught. Sir, if I want to find I naught, I need a voltage called VOC, open circuited voltage. Because VT is given, IL is given, I need to find I naught. Of course, VT is given, Vm is given, IL is given. I can easily get the value of Im, which is nothing but a peak current. If I know Im, if I know Vm, if I want to find open circuited voltage, as I know V short, I mean to say short circuited current, at least examiners need to specify what we say. I mean to say, what is this point, dear students? This is the region where the maximum power is getting transferred. And this space, we need to fill factor. We call it as what a fill factor for getting a maximum conversion efficiency of a solar cell. At least examiner need to specify the fill factor. He did not specify the fill factor. He did not give an open circuited voltage. I don't think so. We can find the value of a leakage or a reverse saturation current. If really this is the data given in the question, absolutely you need to get the marks for sure. Otherwise, if any data is missing from the student, I don't know, dear. This is the input what I got from our students. So, frankly speaking, with the given data, you won't get the answer. Okay, please take it as a very important note here, right? And go for very next interesting question. You know, guys, once again a student said that, sir, this is the question given in the exam based on the bipolar junction transistor. Let us check it out. What is the question? Not exactly framing, I don't know exactly what he told. We have written on the screen, guys, okay? So he told that given 4 statements of BJT regarding beta, you know that it's a current gain, right? It's a current gain of a bipolar junction transistor. They have given 4 different statements, it seems. You know, beta saturation less than beta forward active, okay? Under high level injection, if collector current increases, beta decreases. Under low level injection, if collector current increases, beta decreases. And higher the beta leads to smaller the breakdown voltage. Out of 4 statements, which statement is correct? This is the question asked in this exam. Very interesting question. I think by seeing this, you can directly say that this is absolutely correct statement. Why? Beta saturation less than beta forward active, absolutely valid if the BJT quiescent point is selected in the saturation region. If it is in the saturation region, beta sat must be less than beta forward active, it is absolutely apt. Whereas here he is asking to check for high level injection as well as low level injection. I hope a number of times I discussed this point in the class regarding the high level as well as low level injection. Have a look onto the screen, my dear students. I hope you know that. Guys, this is what we call it as input junction, or we say emitter junction. Correct or not, dear students? In the similar way, this is taken as output junction, or we say collector junction. True or not, dear students, right? You know, please tell me, see here, this is the force, we say junction force, and this is, I'm sorry, here it must be, right, here it must be negative ions, not here, sorry, just a minute. It must be negative ions because p-type semiconductor, and here we get a positive ions because of n-type semiconductor. So this is the direction where we get a force, which is the junction force. Now speak out, guys. Whenever I say low level injection, let me say low level injection. Speak out, guys. Whenever we go with a low level injection, no doubt this is the smaller voltage we are supposed to provide. The voltage we are providing here must be smaller value. So because of that, there is a force acting on electrons, external force acting on electrons, which must be a smaller force. Excuse me, correct or not? There is a force acting on electron, which is a smaller force. Now, because of that force, see, these electrons can easily cross the junction, and they may fall here and they may touch here. Because of that, some electrons could be reaching to the collector, and the remaining electrons can be participating in the current in the base, so-called recombination. As electrons are falling down, no doubt current is upward, we say recombination current. As electrons are coming out, there is a drift current, which is nothing but IC. Yes, this is low level injection, we know that. Now let me say, if I am giving large voltage, see, this is a high level injection. This is what, dear students, high level injection. High level injection. Now speak out, students, everybody in the class. I think here we are providing large voltage. Whenever voltage is very large, yes, absolutely, this external force acting on electrons are very high. So due to that largest external force, no doubt this electron can easily cross the junction, but many students may think that this electron can directly go to the collector. No, don't forget, not only this negative polarity, also the positive polarity magnitude is very high. Because of that, there exists a huge attraction. So the attraction force is very high, and the carriers moving towards the positive terminal will be very high. Indicates what do you mean by that? Under high level injection, emitter current may be increased, but the carriers reaching to the collector is getting decreased. Because of that, gain will be getting decreased. That means what? That means what? Beta increases. If you are expecting beta increases, I mean to say, if you are expecting large gain, that is not at all possible in case of a high level injection. If you are expecting large collector current, that means IC may get increased. Why IC? Because IC is almost equal to IE, right? IC is almost equal to IE. So IE may be increased, which is almost like IC may be increased. But don't forget, beta must be getting decreased. The gain will be getting decreased whenever I go with a high level injection. Whereas at a low level injection, that is not the case. At low level injection, no doubt, if IC increases, no doubt beta will be getting increased. Why? Because here we give a large voltage. Because of the large voltage, large negative ions exist, large positive ions exist. Electrons can be easily attracted towards the collector. because of the drifting force at the collector junction, we will be getting a large current. That means at a low level injection, IC increases, beta increases. At high level injection, IC increases, beta decreases. Therefore, if I draw the graph between collector current and beta, for example, I say if this is beta, this is IC, you know, the graph seems to be like this. This is at a low level injection, and that is at what here? High level injection. I believe you got the point or not. Now speak out, guys. Speak out. So under high level injection, speak out. Under high level injection, IC increases, beta decreases. Under high level injection, IC increases, beta decreases. This is absolutely right. Whereas under low level injection, IC increases, beta should increase. But examiner has given beta decrease, which is absolutely wrong. Right? Now let us go with the fourth option. Higher beta leads to smaller breakdown voltage. This is very simple, man. You know that higher the doping, I think you know that whenever doping increases, collector current increases. If collector current increases, beta increases, correct or not? Higher the doping, higher the collector current, higher the collector current, higher will be the beta. But don't forget, whenever doping is high, breakdown voltage will be small. Whenever doping increases, breakdown voltage will be decreasing. So doping increases, beta increases. Doping increases, breakdown voltage decreases. Therefore, beta increases, breakdown voltage decreases. Therefore, absolutely option D is apt. Therefore, for the given question, option A, option B and option D are absolutely apt options for the given numerical, which is again a multiple select question. Let's go to one more interesting question they asked in the exam. Have a look onto the screen, guys. Yes, again this is the input what we got from our students, guys, ACE Academy. If you check it out, that the given system is NMOS. Okay, they have given NMOS MOSFET, and the device is operating under linear region. I hope you know that. Whenever I say linear region, that shows my device is operating under triode. Correct or not, dear students? Saturation region is also called as pentode, whereas here it is what here? Triode. And of course, ID is given as what? 5 microamps. That means when the MOSFET is operating under linear region, the quiescent point is 5 microamps at VDS is equals to 0.1 volt. Right, take care. Now VGS is given constant, okay, they are fixing the VGS value, and now VDS is increased from 0.1 volt to 1.5 volt. This is very interesting. Now the new voltage what we got here is what here? 1.5 volt. And given mu n Cox W by L, which is nothing but a process transconductance parameter, they have given as 50 microamps per volt square. Now find transconductance at new operating point. This is very interesting. At the new operating point, we are supposed to find the transconductance. I really don't know. The new operating point is under saturation or linear. The old operating point is under triode, which is a linear region. But the new operating point, I'm sorry to say, I don't know whether it is linear or saturation. Let us check it out that point. Now speak out, guys, everybody in the class. So since linear, because it is under triode. Now speak out, guys, what will be the current? So ID is equals to, speak out, guys, mu n Cox W by L into VGS minus VT into VDS minus VDS square by 2. Excuse me, correct or not? Now speak out what is the ID value. The Q point is 5 microamps, which is equals to, guys, what is mu n Cox W by L? Mu n Cox W 50 microamps. Yes, it is 50 microamps per volt square, right? 50 microamps per volt square into VGS minus VT. We don't know that. VGS minus VT. Now speak out, guys, into VDS. What is VDS they have given? VDS, yes, Q point is 0.1 volt. So this is 0.1 minus 0.1 whole square by 2. Guys, okay. So from here, we are supposed to find the value for VGS minus VT. If you could find the value for VGS minus VT, you will be getting it as almost like a 1.05 volt. And for your kind information, VGS minus VT is nothing but a overdriven voltage, correct or not? Therefore, overdriven voltage, or we say VGS minus VT, what we got here is 1.05 volt. Now please tell me what is the new operating voltage VDS? New VDS is how much given new operating point. What is new VDS, guys? New VDS, new VDS, yes, 1.5 volt, right? So new operating point, what we got here is 1.5 volt. Therefore, I'm happy to say VDS value is greater than VGS minus VTH. What it represent? Now Q point is under saturation. This is interesting. Now Q point is in saturation. Wow. Now Q point is under saturation. Now speak out, guys, whenever quiescent point is under saturation, what will be the transconductance? Simple answer. GM is equals to mu n Cox double by L into VGS minus VTH. That's it. Now mu n Cox double by L is given, VGS minus VTH just now we got, that is 1.05 volt. If I could substitute, I can get the value of a transconductance. That's what the transconductance, I hope I calculated already. Yes, anyways, you can put pen on the paper, I hope you can get the answer. Understanding or not, dear students, right? So like that, you got multiple questions in the exam. Last but not least question, what I got data from the student. Have a look onto the screen, guys. Given MOS cap, okay, MOS capacitor they have given, that's interesting, with a P substrate. It itself shows, represents what, dear students? When our substrate is P type, it is NMOS, right? It is NMOS. Fine. Now speak out. What is oxide thickness? TOX, 100 nanometer. And what is oxide charge, okay, per unit area? 10 power minus 8 cubic per centimeter square. And what is this? Q times phi m, which is nothing but work function, metal work function, correct or not? Metal indicates it is a gate work function. Gate work function, superb. So examiner has given the gate work function, which is a 4.6 electron volt. In the exam, if they have given only volt, then you should take only phi m. In the exam, if they have given as electron volt, you are supposed to multiply with the Q. Don't forget about that, because it is energy, representation of energy. Now epsilon r, they have given 4 for silicon dioxide, and epsilon naught, absolute value 8.86 in 10 to the minus 14 farad per centimeter. Now flat band voltage, very interesting. Flat band voltage is 0. Now speak out what we are supposed to find. We need to find the work function of P-type substrate, that is a Q times phi s. Very easy question, man. Have you remembered the formula, dears? Whenever I say flat band voltage, it is nothing but flat band voltage 1 plus flat band voltage 2. Correct or not, dear student? What is flat band voltage 1? Which is nothing but Q dash ox by Cox, this is nothing but phi ms minus Q dash oxide by COX dash. What is phi ms? I think it is very easy now. I think flat band voltage is given as 0, which is nothing but phi m minus phi s minus Q dash oxide by COX dash. Right. Finally, we are supposed to find what here phi s. Therefore, phi s is equals to phi m minus Q dash oxide by COX dash. I think examiner has given everything. QM is given, okay, QX dash is given, and the COX dash we need to find. So I think it is equals to, speak it guys, can I write like this? It is equals to phi m minus Q dash oxide by Cox, which is nothing but what here? Epsilon ox by tox. I know what is epsilon ox. Epsilon naught into epsilon r of silicon dioxide, 4 into epsilon naught by tox. If I can substitute everything, I can easily get the answer, and it is like 4.32 electron volt. You please have a back test by solving the part here. I think it is very easy question. So I hope these are the questions what we got input from different students of ACE Academy. I hope you gave up excellent years. This is the year where we got 12 marks, a huge number of questions in electronic devices, a very high weightage. So take care, dears, have a best wishes, have a healthy and wealthy career. Thank you so much. My colleague will be continued.
Very good evening, students. Let us see the questions given in communication systems in today's ECE gate paper. Questions were pretty direct only, and most of the questions were covered in class and any of the online batches. Let us see the questions. So this is relating with the system, additive weight Gaussian noise having zero mean with some power spectral density. It is given to a RC low pass filter. So he is asking what is the power of the noise coming at the output of the filter. Very simple question. Okay. So what you can do here, the system is a simple RC low pass filter. So these things you have to be very sharp, no need to do the entire analysis again. You know this transfer function. The value of h of f is 1 by 1 plus j into f by fc, where that fc represents the cutoff frequency of that filter, which is 1 by 2 pi rc, finish. Now what is the power spectral density at the output? It would be input power spectral density, which is n0 by 2 multiplied by mod of h of f whole square. So it will become 1 by 1 plus f by fc whole square, finish. So what is he asking? He is simply asking what is the power of the noise at the output. So what is this P0? You will get by integrating this output power spectral density. So obviously your low pass filter, whatever you are defining, is defined over all frequencies. So the output that you are going to get has to be integrated from minus infinite to plus infinite, n0 by 2, 1 by 1 plus f by fc whole square df, finish. So what would be this value now? Therefore the power of the noise coming at the output of your filter will be n0 by 2 is a constant. You will get a tan inverse of that function. When you take the limit pi by 2 minus of minus pi by 2 will be pi into 1 by fc will be fc. Fc is nothing but that 1 by 2 pi rc, finish. So this pi and pi will get cancelled. So this value will become n0 by 4 into rc in watts. That's all. So this question I have covered in class for classroom batches as well as for all online batches. So your answer will be n0 by 4 into rc. Done? Right. So most probably it will be a 2 marks bit only. Next, let us see the next question. A source transmits symbols from an alphabet of size 16, the value of maximum achievable entropy. So what is the maximum possible value of entropy? It becomes maximum when all the events are equally probable, and it is log that value of number of events to the base 2. So you will get directly 4 bits per alphabet, or simply you can write it as bits or bits per symbol. So anyhow he is asking in bits, so definitely your option should be 4. It's a numerical type question, so it will become 4. Okay, straightforward question, 1 mark bit mostly. Coming to the next question, see this one. A digital communication system transmits noiseless band limited channel. So he is talking about a channel. The received signal at the output of receiving filter is given. So this is the output. So channel is noiseless, very clear. E of n are the symbols and x of t is the overall system response to single symbol at the received sample at t equal to mt. The Fourier transformation of x of t is x of f, Nyquist condition to satisfy 0 ISI. So what is your requirement? There is no noise present in the system. What is the requirement for having 0 intersymbol interference? Okay, so what would be the required condition? We have derived this in classes also. If x of t is your system pulse or pulse that you are representing, having some Fourier transform x of f. So intersymbol interference will be 0 only when 1 by ts summation x of f minus n by ts or n into fs will be equal to the value of the function x of t at t equal to 0. This is the required condition. Okay. So what is the summation x of f minus n into ts, n by ts, or you can write n into fs, both are same. Summation on all integer values of n should be equal to the value of Ts into the value of x of t at t equal to 0. So this condition whatever is satisfied by your function will give you 0 ISI. So which will be your possible choice as per the given options? You can check here very clearly on the right side part only we are having this option and this option. So you can eliminate A and B, and out of these two right side part T is valid here, T is valid here, but you should have M by Ts or M by T. T or Ts are both sampling time only. So only possible choice is C, that is it, over. So that is how once you remember the condition easily we can find the answer, okay. Only one step, that is all. If you remember this one equation, that is enough. So this value of x of t at t equal to 0, I think here you are assuming it as 1. So you can easily map with your options. Next, let us see the next question. So here he is talking about a modulated signal for standard AM, okay. So here if you observe carefully, obviously this will be your lower sideband, this will be your upper sideband, and this will be your carrier, correct or not? 200 Hz, 180 Hz and 220 Hz, very clear. So what is he saying? Power in the carrier is 50 watts. So when power in carrier is 50 watts, meaning is AC square by 2 is 50. So value of AC will be automatically 10 volts. And the total sideband power to total power is 1 by 9. It is single tone modulation. So mu square by 2 plus mu square happens to be 1 by 9. So 9 into mu square will be 2 plus mu square. So you can get 8 mu square as 2. So value of mu will be 1 by 2 or 0.5, finish. Okay. Now what is he asking? What is the value of B in volts? What is B? Is it representing the coefficient of either upper sideband or lower sideband or not? For single tone modulation, you know its value is AC mu by 2. Now equate this with B. So value of AC we got 10, mu we got 1 by 2. So this value becomes 1 by 4 equal to B. So what is the value of B? It becomes 2.5 volts, finish. Straightforward question, directly based on single tone modulation of standard AM system. Right. Let us go to the next question. Yeah. This question we could not type it. I will just give the data and see what is asked. So here he is saying that x and y are identically distributed independent random variables, okay. Both are uniform random variables. So x is a uniform random variable from 0 to 1. So obviously your f of x is equal to 1, and y is also a uniform random variable from 0 to 1. So this value is also 1, this becomes your f of y, clear? Now because x and y are said to be independent random variables, you can take a joint probability distribution density function as product of individual probability density functions. So this is a very important point when you are considering a joint density function. Now what he asked, he is asking what is the probability of x greater than or equal to y? Fill in the blank, like a numerical type question. So how you can write this? You can write a probability of y less than x, correct or not? X should be greater than or equal to y, or you can say that the value of y should be less than x. So I can take the integral of your probability density function, joint probability density function, where my values of y are between 0 to x, because y should be less than x, but x has no limit, it can be from 0 to 1. Now that f of x comma y I can write as f of x into f of y, dx dy, finish. So here first integrate with respect to y, limit on x I am keeping from 0 to 1. So this f of x and f of y both are 1. When you integrate with respect to y you will get y, when you substitute the limit you will get x, dx. So it will be x square by 2, when you substitute the limit it becomes 1 by 2 or 0.5. So this is how simple mathematics you can use and get the result. Okay? Right. Next, one more question is also there. Just let me check it out. Yeah, this one. So here he has given a random process as x of t equal to capital A cos of omega naught t plus theta. This is a given random process, and the autocorrelation function of this random process is 2 by 3 into cos omega naught tau. Okay? And A is a uniform random variable distributed uniformly in the interval from -2 to +2. That means you are considering your random variable as A from -2 to +2. So obviously your f of A should become 1 by 4. Okay? This is the data, and theta is also a uniform random variable which is distributed in the interval from 0 to 2 pi. So now here your x-axis is theta and distributed uniformly in the interval from 0 to 2 pi. So your y-axis will be f of theta equal to 1 by 2 pi. Finish. So this is the points given. Now he is asking what is the signal to noise ratio or signal to quantization noise ratio in dB. Okay, and the quantizer used here is an 8-bit PCM system or 8-bit PCM modulator is used. That means it is based on baseband data transmission scheme. So how will you get the signal power? The signal power is obtained directly by taking the value of your autocorrelation function at tau equal to 0. So this value becomes 2 by 3. And what is the quantization noise power? It is a del square by 12, because when you take PCM system you will use a uniform quantizer. So what is this delta? V max minus V minimum, this is your signal. So it will be 4 by 2 power n, it becomes 2 power 8, 256. So this becomes 1 by 4, 6, 24, 1, 64. So your quantization noise power will be 1 by 64 into 64 into 12. So therefore, what would be your signal to quantization noise ratio? Signal power is 2 by 3. Quantization noise power, when you divide, you will get in numerator all these terms 64 into 64 into 12. So this 3 goes here 4 times, 8 into 64 into 64, you will get 32,768. So when you apply this log, he is asking in dB, so it will be 10 log 32,768 to the base 10. So this value comes out to be 45.15 dB. So that should be your final answer. Okay? So this is how you can do this. This comes under the category of baseband data transmission. Direct bit only, there is nothing difficult here. Easily you can do it. So these are 6 questions. So let us come to the last one. This is the last question given. Only this is a little bit a typical question, not difficult. I have covered this in class also. So let us see this question, we can wind up. So here he is considering 3 symbols. All the symbols are equally probable. So I am writing P of S1 equal to P of S2 equal to P of S3 as 1 by 3. That is the first point. Now what about noise? Noise he is considering as additive weight Gaussian noise. Okay. Now when you take the density function of the received signal, you are having the Gaussian density functions like this. So this is how he has represented. So your x-axis is like your received signal, which is a combination of a signal with noise. Okay. And the mean value of the first one is -4, and for the second signal is 0, and for the third signal it is 4. So these are your signals S1, S2 and S3. So what is the question is asking? What is the total probability of error in terms of Q functions? This is what you have to find. Okay, very good 2 marks question. So this is the only question, little bit difficult. Okay. Now basically because all these 3 symbols are equally probable, what is the threshold voltage that you have to take using MAP algorithm? MAP algorithm when you take, when probabilities are equal, the second term in optimum threshold voltage will become 0. So first term is like V1 plus V2 by 2. So if you take these 2 symbols, the mid value here, this value becomes your first threshold. So this is like VT1. So this value is like -2. And for the symbols S2 and S3, the second threshold voltage is mid value, which is your 2. So what are the probabilities that you can expect here? When you take probabilities of, let us assume S1 transmitted, but it is decoded as S2. So this is one error event. So when this will happen, when you have transmitted S1, what is your voltage of transmitted signal? -4 added with noise. If it has to be decoded as S2, what is the required condition? The value of voltage that you are getting should be greater than or equal to -2, correct or not? Then only S1 transmitted will become S2 received. That means the noise value should be greater than or equal to 2 volts. So what is the probability of noise greater than or equal to 2 volts? Probability of noise greater than or equal to 2, or you can write 1 minus the probability of noise less than 2. So this is nothing but 1 minus the value of the distribution function of noise at 2. That means 1 minus Q of that 2 minus mean value is 0 by variance is given as 4. So sigma becomes 2. So the variance of this particular channel is given to as 4. So sigma value automatically becomes 2. So this value happens to be Q of 1. Is it clear or not? So if you get this point correctly, then you can do the remaining part easily. So what we got? Probability of error that S1 transmitted decoded as S2 is 1 by 3. Similarly, the probability of error that S3 transmitted decoded as S2 will also be 1 by 3 only. So S1 transmitted becoming S2 or S3 transmitted become S2, both values are same. Now here you have to be careful. There is every chance that S2 transmitted might become S1 or S2 transmitted may also become S3. That means probability of error that S2 transmitted becoming S1, this also comes out to be 1 by 3, and probability of error when S2 transmitted can becoming S3 is also 1 by 3. That means what is the meaning? There is every chance that S2 will have more suffer on noise rather than on S1 and S3. So what will be your total probability of error? Add all these values. You are getting 1 by 3 how many times? 4 times. So it will be 4 by 3 into Q of 1. That's all. Over. So this will be your correct choice. Because this is Q of 1. All these errors are Q of 1 only. So probability of error, this value, just a moment. Yeah, this is like P of S1 transmitted as S2, 1 by 3 into Q of 1. Because probability you have to multiply and then this value. So you will get 4 by 3 into Q1 when you add all the 4 values. So this will be your final answer. Right. Is it clear? So this is the only question little bit typical, but all the remaining things are very, very simple. And this question if you see, I think in 2020 or 19, same question was asked. He has given S1, S2, S3 and asked which is a symbol that will have maximum probability of error. So it is S2 that time. And from that year onwards I am explaining the same question in class. You can expect this bit, you can expect this bit. So this was given after 3 years. So little more complicated what they can ask, they can tell the probabilities of S1, S2, S3 are different. Then what would be the total probability of error? So that is the next level of question that you can expect. So these are all the 7 questions that were given in communication point of view. Hope you have done well in this. equations. Nothing very difficult, very much direct, and all these are covered very well in our classes. So I hope you have done well. My next colleague will take the remaining part of the topics. Thank you.
Okay, welcome back. See here, I am going to deal with the questions which are related to the electromagnetic theory. As of now, we have got 3 questions. Okay, in one question we do not have a sufficient data, but other 2 questions are very clear. Let us deal with this question. This is related to the transmission line. A transmission line with the characteristic impedance Z0 is equal to 50 ohms is terminated with the unknown load. The magnitude of the reflection coefficient is 0.6. As one moves towards the generator from the load, the maximum value of the input impedance magnitude looking towards the load is. Yes, let us draw some diagram here. Here is a transmission line. This is connected to the load ZL, unknown load, and this is Z0. Fine. So somewhere here the maxima is noticed. It is asking what is the impedance there. Okay. So at the maxima point, the impedance measured is R maxima, which is given by Z0 into rho, where rho is VSWR. Fine. So the rho is equal to 1 plus magnitude of the reflection coefficient divided by 1 minus magnitude of reflection coefficient, which is equal to 1 plus 0.6 divided by 1 minus 0.6, which will turn out to be 4. Fine. So you can directly use the formula. This model was discussed in the classroom. Fine. So this is a very straightforward question. 50 into 4, which is equal to 200 is the answer. Fine. Suppose if this is a minima, if this would have minimum question, then this would have 200 divided by 4. Fine. So it is the maxima. So this is all about this. Next question. Yes. So this is a very simple question. Which of the following represents the electrostatic field? The 2 fields was given, is asking which of the following is the electrostatic field. We know that electrostatic field is a conservative field. So what is the conservative field? We know that curl of E must be equal to 0, or closed line integral of E dl is equal to 0. No limits was mentioned in the question. So let us try to find out the curl of E. Curl of F1. So what is the curl of F1? Which is equal to determinant of x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. What is the x component? X component, I will just ignore these constants here, fine, during the calculation. Why? Because even though if I write the constants in the determinant, I can bring them outside. Okay, that doesn't matter. So it is x, this one is 0. Clear? Fine. Perform the determinant here. X cap into this minus this into this, 0 minus 0, minus y cap into this minus this into this, 0 minus 0, plus z cap into this minus this into this. It is 1 minus 1. So which is 0 plus 0 plus 0, it is 0, null vector can be written as a 0. Fine. So let us check the same thing for the F2. F2 is equal to determinant of x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. What is the x component here? You can ignore that constant part. So the x component is y component is minus x. The only difference is here minus x, which is equal to 0. Here it is 0, z component, fine. So which is equal to x cap into this minus this into this, 0 minus 0, minus y cap into this into this minus this into this, 0 minus 0, plus z cap into this into this minus this into this. It is minus 1 minus 1. So it is minus 2, obviously, which is not equal to 0. So as curl of F1 is equal to 0, F2 is not equal to 0, only F1 is a electrostatic field. Fine, F2 is not electrostatic, F2 is not representing the electrostatic field. So these are the two questions we have a perfect information. The third one we do not have a sufficient information, but there are a lot of things need to be clarified in the third question. There may be some other questions as well, but we do not have any input from the other questions. So let me write down the one question here. So there is an incident electric field. Incident electric field is equal to some constant A into e to the power of minus j 2 pi by 3 into x y cap. This is traveling in the free space, is incident on the, this is traveling in the free space and incident on the perfect conductor. Yes, so we'll call this as a medium 1, this as a medium 2. The coordinate system is mentioned. Yes, so here x is equal to, at the x is equal to 0, there is a media interface. Whether this is x less than 0 or x greater than 0, we are not sure. So, but just for the sake, we are considering it as a x greater than or equal to 0 here. Here also greater than or equal to 0, we do not have any idea how the coordinate system is defined. So it is asking, so because of this incident and reflection, there is a standing wave pattern. So at what distance from the interface, there is a null we will find for the electric field standing wave pattern. Some are saying electric field standing wave pattern, some are saying it has a magnetic field standing wave pattern. So we do not have any clarity over the question. Fine. So but still you can write this one in the harmonic form. You can multiply this one with the e to the power of j omega t, and you can take the real part of that. So it will become a cos omega t minus 2 pi by 3 into y. Fine. Obviously the wave is traveling in the positive x direction. So positive x direction in the sense, obviously this must be positive x. So this must be positive x, this must be negative x. Okay, anyhow. So we do not have sufficient information. So what is the reflection coefficient here? The reflection coefficient here, it is a free space, eta 1 is equal to 120 pi ohms. Here eta 2, which is equal to 0. For the perfect conductor, intrinsic impedance is 0. Fine. So what happened? It is said that it is a normal incidence. So reflection coefficient is eta 2 minus eta 1 divided by eta 2 plus eta 1, which will going to get minus 1. So what is the reflected wave here? The reflected wave is equal to minus of this. But you have to make some adjustment here. It must be incident. If the incident wave is traveling in the positive x direction, reflected wave will be in the negative x direction. Omega t plus 2 pi by 3 into x into y. So for the standing wave pattern, these two things must be added. Fine, let me turn the page here. So the E total is equal to incident plus reflection. Incident is equal to A cos omega t minus 2 pi by 3 into x minus A into cos omega t plus 2 pi by 3 into y. Don't forget that unit vector y cap. So it is, this can be written as 2 sin, this can be written as 2a sin omega t sin 2 pi by 3 into x. So he is asking for 0. So you have to make E total is equal to 0. So that happens only when sin of 2 pi by 3 into x. One point here, it is unit vector y cap. So you have to make this part equal to 0. This part happens to be 0 only when 2 pi by 3 into x, which is equal to plus or minus m pi. Fine. So from here you will going to get x is equal to plus or minus 3m by 2. So he is asking in the options, hope he would have given some non-zero values. So for m is equal to 0, so the first null will going to appear at x is equal to 0, and second one x is equal to plus or minus 3 by 2. You have to make the adjustment of whether it is a plus or minus according to the coordinate system. Fine. So remember here the first non-zero value at this point from the interface there will be a null. There is a minima for the electric field standard standing wave pattern. Suppose if the question was for the magnetic field standing wave pattern, you can apply what is called image theory. Fine. Suppose if the electric field is like this, magnetic field is reverse. Fine. So here you are getting 0, here you are getting 0, distance here is 3 by 2. So this one will be 3 by 4. Fine. Suppose answer is plus or minus 3 by 4 for the electric field, but in the question if the magnetic field was given, then let me call this as x dash, which is equal to plus or minus 3 by 4. This is answer for magnetic field, that is answer for electric field. So according to the question you need to react. Fine. So this is all for now. We do not have a sufficient information regarding the other questions. Fine. So we will be updating you about the remaining question as and when the time comes. Fine. So all the best. Hope you people have done well. So now I will hand over the session to the other colleague member. Thank you. Good luck.
Hello my dear friends, from the general aptitude we are getting only 3 questions from the students' source. These 3 also I hope everybody is getting good. Okay, our A students, online, offline, recording students, anybody also, I hope everybody is getting. These 3 questions approximately 5 marks, easily are getting. Okay my dear friends, okay. So for the real numbers x greater than y, x greater than 1. So 1 by log x base 2, log x base 3, log x base 4 is equal to 1. What is the value of x? Simply, my dear friends, you can use this logic. Okay, you explain number of times. Logarithm is very important, very important. This 24 all branches also given. After the simplification, it is log 2 base x, log 3 base x, log 4 base x. 1 means I written as log x base x here because base is x. Okay, log a plus log b plus log c, log a b c. 2 3 is 6, 6 4 is 24. Log 24 base x is equal to log x base x. Base is equal, then x is equal to 24 is the answer. Okay, completed. Okay friends, maybe it is 1 mark question. Next, the greatest prime factor of the 3 power 199, 3 power minus 3 power 196. You remember in starting classes also I mentioned prime factor. So prime number having 2 factors, so prime number square having 3 factors in that immediately. So prime factor. So 3 power 199, 3 power 196 common, 196 common, then 3 cube minus 1. So this is the prime number 3, 196, 26. 26 written as product of the prime numbers. So 2 into 13. So 3 power 196, 2 into 13. What is the greatest prime factor? So 13 is the answer, my dear friends. Right. The ages ratio of the ages. Okay, I mentioned only 5 questions or 6 questions we discussed in the classroom. So ages abhi tak only 2 times given, and this is the next time. And also ratio and proportion also you can consider. The ages ratio of the Amans and his father age Before 5 years, 1:4. Once ratio is given, then immediately Aman and father. Then immediately Aman age X, father 4X. It is not now, 5 years back. So bring them present. Bring them present. X plus 5, 4X plus 5. After 5 years from the present, that means, so X plus 10 is to 4X plus 10 is equal to what is the given? 2:5 given. So product of extremes, product of the means, 2 fourths 8X plus 20, 5X 50. So 3X is equal to 30, X is equal to 10. So X value substituted here. So present ages, Aman 15, father 45. At the time of the Aman's birth, means 0. At that 15 years back, that means 15 years back father is 30. So age of the father, Aman's father at the time of the Aman's birth is 30 years. Okay, my dear friends, these 3 questions only getting the source from our students. Okay, next our mathematics faculty Aditya sir taking some questions.
Let us look at the questions from engineering mathematics. This is a very simple question. They give a complementary function and some options were given. You need to identify which of the following is the corresponding differential equation. Now observe this, e power minus 2t. So that means if the roots of the complementary function are like this, if the roots are like minus 2 comma minus 2, only then you will get that kind of complementary function. So what could be the differential equation? It would be like this, the second derivative of y plus 4 times, because you need to look at like this, the first derivative 4 times this plus 4 into y of t equal to some, let's say, f of t. So when the differential equation is like this, only then you will get this kind of complementary function. This was one of the option. You can go through the auxiliary equation, find the roots, so you will get these roots. Let's go to the next problem. So here, so already this kind of question already appeared in data science. They say that x and y are independent random variables. So they are identically distributed and they are uniformly distributed in the interval 0 to 1. What's the probability of x greater than or equal to y? So clearly x and y are uniformly distributed in the interval 0 to 1. So you can draw a square like this is 0, this is 1, this is 1. Now why don't you look at x equal to y line. So how does that look? It looks like this. So they are asking you what's the probability of x greater than or equal to y, which is same as y less than or equal to x. So what is that region where y is less than or equal to x? So obviously this is that region where y is less than or equal to x. So what's the probability? So it's a total area, that is 1 into 1, and the area of this shaded part is half, base is 1, height is 1, so the overall answer is 0.5. Such a simple problem was asked. Now this was a MSQ 2-mark question from linear algebra. They gave a matrix like this and they are asking which of the following are the eigenvectors for the given matrix. So what you have to do is first find the characteristic equation, find the roots, that is the eigenvalues, and then you need to use this Ax equal to lambda x. So when you look at this, I found that these 2 options are satisfying. You can also go through it. First find the characteristic equation, find the roots. From that you do this verification. So this is one of the procedure. There could be other procedures as well. Now this was a very interesting question. This was also a MSQ. Okay, so they say that f1, f2, f3 are functions of x, y, z. So they create an integral like this, integral f1 dx plus f2 dy plus f3 dz. So it is integrated from a to b. So they say that
there are many paths, so which are from A to B. So when you evaluate over all such paths, the answer was same itself. That means this integral is independent of the path. That means the given vector function is curl free or conservative or irrotational. So based on this, you need to find what is the right answer. So when f, or you can write like this, so you can treat f bar as f1 I plus f2 j plus f3 k. So what we finally understand is it's a irrotational vector or a conservative vector or curl free vector. So the first option says the divergence of f bar is 0. No, so there is no link between this, so this can be eliminated. Now look at this, when you try to find the curl, when you expand this, how do you find the curl? So curl of f bar, so it's like this I j k dou by dou x, dou by dou y, dou by dou z, and then f1, f2, f3. When you expand this, you get 3 terms. You need to equate each term to 0. When you equate, it will definitely match with this. Now when f bar is curl free, so you can always express that vector as gradient of some scalar function. That was given in this, yes, that is also true. And when you are integrating a curl free vector along the closed contour, the value of the closed contour is also 0. So this was a very interesting MSQ. This time, so from mathematics itself, we had 2 MSQs. Now this is a very regular question from complex variables. So you can do it in many ways. I have calculated residues. I calculated residue at 0, I calculated residue at 2. So for calculating residue at z equal to 0, I treated z equal to 0 as pole of order 1. Most of the students obviously treat z equal to 0 as pole of order 2. No, there is a pole 0 cancellation. So if a student has solved similar problems, they will understand this. So you need to find the residue at z equal to 0. So I will just write that residue. So I will just write like this, at z equal to 0. So how do you find the residue? So it is limit z tends to 0, z into sine pi z by z square into z minus 2. So after cancellation, so after substituting these limits, so obviously you get this answer as minus pi by 2. So if you want, you can use L'Hospital rule or whatever, sine pi z by pi z tends to 1 as z tends to 0, you can use that concept. So I got this as minus pi by 2. When you try to find the residue at z equal to 2, it turns out to be 0. So you need to not find the other residue. What would be the final answer? According to the Cauchy's residue theorem, this value is 2 pi I times sum of the residues. So one of the residue is minus pi by 2. At z equal to 2, the residue was 0. So now this gives you, this cancel, minus pi square I is the answer. So this was also one of the interesting question. Now this was very simple. So he says there are 3 vectors, and he says that what should be the value of alpha so that they do not form the basis. So one logic is, if you want these vectors not to form a basis, that means they must be linearly dependent. The moment you say that this is linearly dependent, so what you can do is you can equate the determinant. You can equate the determinant to 0. So this is the procedure, students. I leave this activity to you. So if you equate, you will get the value of alpha. So let's look at the other, so these are the questions from engineering mathematics. I hope you have all learned something new from this. I hope you have matched your answers with our answers. So I thank everyone for watching the video.